Let O and H be the circumcenter and the orthocenter of an acute triangle ABC. Points M and D lie on side BC, such that BM is equal to CM and angle BAD is equal to angle CAD. Ray MO intersects the circumcircle of triangle BHC and point N. Prove that angle ADO is equal to angle HAN. So let's go ahead and draw those lines. So we want to prove that these two angles are equal. How do we go about doing this? Well, we have these two angles thrown in the middle of nowhere. And the best way we can relate two angles thrown in the middle of nowhere is to try using similar triangles. More specifically, we want to try coming up with a similar triangle that's related to ADO that is similar to something related to triangle HAN. And it doesn't seem we can do much with triangle ADO because AO is a diameter line and we don't have the circumcircle of ABC yet. That's not in the picture yet. So it doesn't seem we can do much with ADO. So let's try working with triangle HAN. And indeed, extending AN won't work because we don't really know what AN is, but we know what AH is. It's the altitude. So we can go ahead and extend that real quick. So end up going to a point Y here and a point X here. So Y is the foot of the altitude from A to BC, and X is the second intersection of AY with the circumcircle of BHC. In fact, since angle BHC is equal to 180 minus A, and that means that angle BXC is equal to angle A, which means that X is a reflection of A across BC, implying that the circumcircle of BHC is just the circumcircle of ABC reflected across BC, which is something useful to know. So, and all right. So now let's see if the point Y will give us a similar triangles. If we draw the line AY, or NY, sorry, then angle AYN is much larger than angle DAO. So that won't work. So let's go ahead and erase Y. But if we take a look at point X here, then we have the line ND and then hit X. ND and X are collinear because N is the arc midpoint and XD bisects angle BXC by reflections. And it definitely seems like X does the job. More specifically, we conjecture that triangle XAN is similar to triangle ADO. And if we could prove this conjecture, then angle ADO is equal to angle XAN by similar triangle counterparts, and angle XAN is equal to angle HAN. So this conjecture would single-handedly solve the problem. So let me go ahead and outline the similar triangles in red. So ADO, and then X, this is X here, and then XAN. So those are the two triangles we want to prove are similar. So the first step in proving these two triangles are similar is to try finding another angle. Because we always like getting more angles because that will give us better stuff. So looking at the angles here, it seems like proving that angle DAO is equal to angle AXN is doable. So let's prove that angle DAO is equal to angle X is equal to angle AXN. So an angle DAO, it turns out that it's equal to angle HAO because AH and AO are isogonal segments, which means that angle BAH is equal to angle CAO. I won't give it a detailed proof here, but the main idea is that this angle here is 90 minus b, and since angle AOC is 2b, that means that this angle is also 90 minus c because AOC is isosceles. This means that angle HAD is equal to angle DAO. So that's angle HAD, sorry. So an angle HAD is equal to angle XAD. But since X is a reflection of A across BC, that means that AD is equal to DX. And hence these two angles are equal. So now we have one pair of equal angles. So the next one we'd like to show, ideally, is that angle AON is equal to angle ANX. Wait, that should be angle AOD. And we again can't really do much with angle AOD because we can't really relate it to the other angles of the triangle. So we can't prove that the last angle is equal to the other last angle. So we can't use AA similarity. Well, what other methods of similarity are there? Well, and we already have one angle, so we are motivated to use the SAS similarity method. And basically, what we want to prove, since we prove that angle DAO is equal to angle AXN, we want to prove that DA over AO is equal to AX over XN. That's what we'd like to prove. Cross multiplying both sides gives us AX times AO is equal to AD times NX. And now we have 3 segments in terms of A. Now we want to get this last segment in terms of A. And at this point, we note that N is a reflection of the arc midpoint Z across BC. So if this is the arc midpoint Z here, then Z is a reflection of N across BC. So that means that XN is equal to AZ. And we can actually get rid of a whole bunch of stuff here. So let's go ahead and get rid of all of this stuff. And let's go ahead and draw on the circumcircle again. Because we pretty much reduced the problem if this is the, we want to prove that AO times AO times AX, we want to prove that it's AD times AZ. How do we go about doing this? Well, noting that seeing the AD times AZ, this motivates us to take a force-overlaid inversion centered at A. Recall my video on force-overlaid inversion, but I'll go ahead and give the highlights. A force-overlaid inversion is a circle, is inverting about a circle centered at A with radius root AB times BC, followed by a reflection across the angle bisector AD. Then the point D gets sent to the point Z under this transformation because points B and C are fixed, and the circles of ABC and the line BC are swapped as a consequence. So AD times AZ, that is AB times AC. And AO times AX, well, we know that X is a reflection, so if we bring this point Y here, then AX is equal to 2AY. And that motivates us to double AO, so we can extend it to this point here, A prime, and then AA prime is equal to AO times 2, which means that AX times AO, that is equal to AY times AA prime. We want to prove that this is the case here. But now note from earlier that lines AH and AO are isogonal to each other. And the lines BC and the circumcircle of ABC invert to each other with respect to the force overlaid inversion. So the point Y, which is the intersection of the perpendicular from A to BC, ends up going to A prime, the intersection of the reflection of AH across the angle bisector with a circumcircle. So Y goes to A prime, and therefore AY times A prime is equal to AB times AC. And we are done. So we have indeed proved that these triangles here are similar. And finally, to conclude, we know that angle ADO is equal to angle XAN, which is equal to angle HAN, as we needed. So thank you so much for watching this video. Please subscribe if you'd like to see more.